All right, let's get going here. Let's see. We've got the stream up. I've got some notes that I had from the other day. You guys should be able to see and hear. Let's make sure that the audio is going through. Yep, sounds good. All right, so we are live on the Twitch side of things. We're on the YouTube side of things. Conrad said, "Is this broadcast sponsored by Trogdor?" It's actually pretty funny. I like Trogdor. Been around the old Homestar runner for a long time. All right, so we're down here on rates and derivates, but if we go up, the whole point of this thing from last week or from the other day was setting up and building this little Prolog Prometheus Certified Associate guide. And even if people don't want to get the certification, right? Even if you tell me, that's not really what I'm interested in, that's fine. This is still helping to get some better skills around Prometheus and how we use Prometheus. I use Prometheus in the home lab. I use it professionally at work with different big high-performance compute clusters. And I really think that Prometheus is one of the simplest and best ways to monitor different systems, right? And then, we went through all this. So this was from the other day, so you can go look at all this stuff. But we talked about different pieces of it. I've got stuff to add in. I've got notes on things I need to fix. But we were down here. We got all through all this stuff. We're not going to go over it again today. But we were down here on how you can look at the rates and the changing values of things. That's what rate and irate do. And those are good, and they're useful for looking at changes of things that have like a steady state, so like a rapid increase, those kind of things. And then there's some functions around them and stuff, and we're going to play with them kind of as we go. But I'm just looking for, as I do this, I'm kind of just putting more and more into some of these examples and stuff. And I've been taking some practice tests on it to see where I'm at. I'm a little under where I want to be, but that's fine because I'm still kind of early in my studying. And whenever you get ready for a cert, there's always like little stuff that you've probably not run into that you got to go spend a little time on. So that's kind of where I'm at as well. All right. So anyway, so we can aggregate over time, right? We can aggregate over a single instance vector resulting in a new vector of fewer elements with aggregated values. So what does that mean? We can see the CPU usage for the last 5 minutes. We can average that. We can sum it and see it as a single value. So we'll grab that here in a second. If you had 500 errors for the last 5 minutes and you wanted to see how many of them there were, this would only be, of course, if you had like an Apache or an Nginx type thing running and you were gathering from that. You can get the number of samples ingested per second averaged over 1 minute window, maybe for your Prometheus. So if we go to our Prometheus labs, by the way, one other thing, let's pull up a couple of things as I start here. You can go here in our Discord and you can find pretty much all this stuff down in our Prolog project section. So if you want to build out your own little Prometheus for free, there's a couple of labs here. If you want to build it out for free in like a home lab environment that you have, there's this here. And then there's a bunch more material and stuff out here for you to study and read about if you are interested in getting better at this. In my case, I'm going to pull up my home lab. So my home lab is right here, right? So boom, I got my little Prometheus system up. And I also got Ranger Dog over here. How's Ranger doing? Look at that dog. He's doing all right. We'll go back to Prometheus, and here we were looking at node ARP entries the other day. But I can come in here and I can say sum by CPU, right? And then I'm going to look at the rate, and we're going to look at node CPU seconds total, right? This in a little bit so we can see it. And then we want not the mode idle. So come back over here now. We want not mode idle. So we're going to use this curly brackets to select not. So mode is not equal to idle. So we don't want to see when it's idle. And we want for the last 5 minutes, right? And then you can, whoops. This thing's trying to help me out and cause some problems here. There we go. Whoops, square bracket. All right. So that looks like a pretty good query. You can also come here and click and see where everything is added up and aggregated. And it looks like I've got everything where it should be. So I'm going to hit execute. And there it goes. It went and grabbed the average. So it did the rate for the node CPU seconds total. That didn't include idle. So there's a bunch of things that it could have included. And we can strip this off and go look at those, because there's a bunch of other values in here. And you can go look at them if you wanted to. Now that included everything. If you want to see just the values you would get from one thing. So this is like, you can deconstruct these commands kind of. And see like, okay, here's all the node CPU seconds. For any instance, I can see the mode idle, and then mode IO wait, IRQ nice. These are all of the normal system things that you might see, right? And I can go and I can gather that information up in the system. So this is just, another way to sum things up and aggregate over time, over a sliding window of time through my system, right? That's kind of a thing. All right. We can look at, I should be able to do this one as well. So this value here, the rate Prometheus, and the reason I should be able to do that is because Prometheus has its own time series database information exposed. So I can construct this command very similar. I can come over here, move this over to the right here, and I can say, well, can I even see this Prometheus stuff? So I have Prometheus TSDB head samples appended total. There we go, right there. So I can actually just execute this and see the information on my system, right? And then I want to see the rate for the last 1 minute in my system. So I'm going to go back here, pull this back up, and I'm going to add rate. And rate will be an equation, and the equation will be over the last 1 minute. And I want that as a single rate. Whoops. Oh, 1 minute. You got to add a time in there, guys. So it's 1 second, 1 minute, 1 hour, that kind of stuff. And what this will do is it'll give me the average rate over that time, right? So we can query and pull a bunch of stuff out of here, and that's aggregating over time. That's like a sliding window over time with the system, right? That's a way to aggregate things, and then you got to go practice and get better at it if that's something you want to do, and if that's something you want to kind of monitor in your system, right? Then there's also aggregating over dimensions. So dimensions are also, they're not completely analogous with labels, because multiple labels can be used to create a dimension. But in some cases, labels are used as dimensions in aggregation, meaning if I want all the instances of a server type in my home lab, I've got these server types that pop up. So if I say, oops, let me come back over here, pull this up. If I said like CPU, let's go node CPU. So if I do like node CPU seconds total, right? I do, oops. Right, and I execute this. What you'll see is this will be all of my systems here, and I can aggregate it like I was just showing in the last slide by time. How's it going, Morrison? We're just doing the PCA and just kind of working through part 2 of it, getting more information out here, and I'm trying to kind of clean up my presentation and kind of think through some of the stuff, so I'm getting that going. But what I wanted to show is the dimension is here. So jobs or nodes or team is infra. So look at all these team infra here. If I want to group all of these up, I can do that. But then when I go down a little bit, I've got these team dungeon. So if I wanted to use the labels as a dimension of aggregation, I can go like this. I can say team is equal to infra, right? And then if I do that, I'll only see team infra stuff, right? So I can, and then when I do my aggregations, it'll be even more like that. Hey, Practical NPC, how's it going? Thanks for the raid. I didn't get to stop in your stream today, but I saw you were on pretty early, I think. And I've been kind of lurking in there during the day. How's it going? What are you guys working on? I will start back over just real quick to show you guys. Going pretty good practical. I've been staying busy, although I had today off of work. What I've been doing is I've been getting ready for the certification, right? It's called the Prometheus Certified Associate. And I run Prometheus in the home lab, right? Like in the home lab, we've got Prometheus. And what Prometheus is a time series database. We throw data at it. You just kind of chuck data at it. And then you get Grafana involved, and you can start to query that data. So let's go look at like CPU here. And in here, this is the looking at the CPU data of all my systems. In fact, I'm only looking at 2 systems here. But like I can sum up and look at the I rate of node CPU total, where the system is instance of node, and then node is a variable up here that I've picked inside of my system, right? So I can come here, and then I can apply it, and I can look at this data. Anyways, the point of while we do this is we want to gather data about systems. We want to be able to look at things over time and say, how healthy is our system? And like here in my home lab, I can see how healthy my systems are. Some of my systems have rebooted yesterday. That's because they're in the lab environment for everybody to use, so they get rebooted. But I can see how much CPU and memory usage I have. But if I didn't have that, I tell people all the time in the systems world, this is what you have right here. This is all you have in this world. You have a black background, letters, and it's like, who am I? Like, I'm root, but what else do I have? Like, I mean, this system's just sitting here looking at me. There's no, like, I'm sitting here at standard input, and it's sitting there ready to give me standard output or error, but there's no, there's like what do I get out of this, right? As a systems engineer. So, and also, how do I hand this off to like my network operations team, where I just want them to see a heads up display of like how healthy my system is, right? So this is why we build tools out like Prometheus. And the whole goal of this study guide here is to help get ready. I'm going to take the test here soon, but it's a 60, look, here it is. It's a 60 question test. You got 90 minutes. You got to get 75%. And I always do well on tests. I've always done well on testing. Cost is $250, but right now they've got it for like $175. So I just figured I'd eat that cost because it's something I do professionally and something, I mean, I'm a Linux systems engineer, right? I'm a platform engineer and a high performance compute guy. But everything I do comes down to how well I can keep track of what's going on in the system. So hopefully that's not too much of a rundown for you guys. But this is the topics, right? The things that we were going over. And then here's the hands-on lab practice that are free. And then I've got those up for people that are around. Those are in my Discord. So these are free labs you can build. And then if people build it in their home lab to be able to track things. But basically it's monitor all the things, right? Just monitor everything, see what's going on, track everything. And we've worked through a lot of this. We worked through building it. I've got stuff to clean up, like if you saw some of my drawings up there. But where we're at now is we were down in aggregating over dimensions. So what we were doing was pulling up our actual Prometheus instance and looking at how we can do these queries, because then we can see what data exists, what data are in the time series database. Then, while this is okay, and while this is also okay, this is not the stuff that we would feed over to a network operations center or different engineering teams. What we would do is we would take this, and then we would go feed it over into a tool like Grafana, where we could make these nice graphs and share it out with our organization, build reports. There's all kinds of things we can do from Grafana. The architecture itself looks kind of like this. So let me pull up my thing here, and I will open, let me just open a file real quick. Let's see if I have in here Prolog Labs. Let's go back here to I think it's under images. No, those are my messing around images. Let me see if I can find where I have this. I think it's part of Linux group, and then I don't know where I have these drawings. I guess I would have thought they were in presentations. Shoot. My brain's failing me, guys. I don't know where my stuff is. Oh, drawings, Excel drawings, right there. So let's go look. This is what my home lab looks like for people that haven't been around for it. Let's go to monitoring. And by the way, if you guys have never played with Excalidraw, Excalidraw is one of my favorite tools ever because I can share this with you right over the browser, and then you guys could see this same exact system, and you could take the drawing and do whatever. But this is like my home lab. And my home lab has any server, John's server, any server, right? Just some server here. And it's got these different agents. Yeah, I think Excalidraw is brilliant. I think it's one of my favorite tools. And it's also open source, so you can run your own version. And it's got a plugin for VS Code. So if you use VS Code at all, for people that use VS Code, you can do that. And full disclosure, I don't normally use VS Code. I'm a Linux guy, so I do a lot of Vim. And, VI and Vim. But one of my buddies convinced me a while back. He's like, just give it a try and play with it. So I do my lab stuff, like my lab building I do in here just to kind of get some experience with it. But strictly speaking, I'm a Linux engineer, right? But I don't care about the tool. I need to get into Linux. So, by the way, I'm missing stuff, but I got the rating, so that's good. And this is this part of it right here. We're looking at Prometheus. Prometheus is a time series database, as is InfluxDB2. So I just built this in the lab environment to have a few different things that can feed over to Grafana. I also use Loki for logs. So we have different types of things that we try to monitor. Logs are what we call any kind of event or discrete action or really, again, event. It should be immutable, but we feed data over to Loki, and Loki is just an API, and then we can call data out of it, right? I have some other monitoring that I need to set up in my home lab, and you might say, well, this is kind of overkill for your home lab. It's true. Professionally, I really only use this one, right? And it's because this one is fast and efficient, and it works, and it's what we're using. But for playing around in the home lab, we build all the different pieces out because why not, right? It's a lab. So that's kind of our thing. All right, so how's Ranger doing? There's my dog Ranger. Ranger Cam is downstairs, and don't let him fool you. I know Phoenix got to 100 and something today. Actually, I don't even know how hot we got today. It says 101 right now, but it got to 111 the other day. But Ranger is 73 downstairs, so yeah, that's Fahrenheit, by the way, too. So don't let him pretend like he is some hard, overworked guard dog or anything. He is pretty lazy, but he's a good animal, so we love him. So there's that. Anyway, so there's all this stuff, and we were aggregating over dimensions, right? We were using labels to aggregate and squish things down via dimensions, all right? So as we do these different pieces and touch all these pieces, that's kind of where we're at. All right, so everybody here is caught up. So then the next one is binary operators, right? We've got binary operators in pretty much every tool that you guys have ever heard of. There's some type of binary operator, and we've got addition, subtraction, multiplication, division, modulo, and then power or exponents or exponentation, right? But here's the operator precedence. And this is important to know if you want to know what order things are going to happen in, right? So what that looks like is, if I come back over here, and I'm going to pull up the Prometheus.io, then they've got their docs, right? We're heavily down in their docs, and we should be able to go look at, they've got all their different concepts and all that stuff. Data model and instrumenting. We should be able to see, where's their actual... Well, I see data model, but it should be here it is. Basics should have it. So they've got some information here. You got to understand these different pieces, and then we should get into range vector selection, all these kind of things, modifiers, how we can modify things, and then maybe I did miss it. Oh, operators right there. Boom. There we go. So here's our arithmetic binary operators, right? You can multiply between two scalars, between an instant vector, something that you've pulled, and a scalar, the two instant vectors. You can do division. You can do all this other stuff. Agents such as node exporter are for individual VM or server you want to collect information from. Yeah. Yep. Manually install an agent on each of them. Yeah, IOSOBU. Yeah, I do have to install. So the question was back here: do I need to put a node exporter agent on all my systems? Yes. However, the question was, do I manually install them? And no, in my case, some of you guys have been around for this before. I have this all deployed via Ansible. So if we cd to root streamer streams code examples Linux in here, and some of you guys have seen this before. We've got this node exporter, right? So when we cd, actually we'll just more roles, node exporter, tasks, main, and in here, this is how I deploy my node exporter to all my different nodes. I just do it via Ansible, some simple little plays. And when I get down here, I go against just my Prometheus node and I deploy the scrape config. This is the scrape config right here for each of my nodes. So like when I deployed this in my cluster, one of my clusters at work that's like 1,260 nodes, I ran this, I deployed it everywhere. I deployed the node exporter, and then on the Prometheus node, it was set up like this, and I had all 1,260 nodes responding in a matter of minutes. So this is the exact same code. I brought this into work. This was code that I had used here at home, and I brought it into work, and I built the same thing on one of my clusters. And then these are just exposing, each of the node exporters are just exposing on a machine. So on this machine, I should be able to curl 127.0.0.1 on port 9100 metrics. Oh, maybe not. Let's see. This one might not have node exporter running because this one's exposed to the world. But if I go to like red 01, one of my dungeon, oh, maybe I can't get to red 1. That's one of my dungeon nodes here. And then on here, I should be able to curl 127.0.0.1 port 9100 metrics. And this will be a page of Prometheus scrapable information. Prometheus scrapes in like the simplest way ever. It's got the for this is the metric here, and it's the node or the name for the metric, and then it's got the value. It's just a key value pair. This is something I had in mind as well. Recently had to do it for Proxmox instance. Granted, the dashboard I used was not node export. ISOBU, by the way, and some of you guys might be wondering this or whatever, and let me just get out in front of it for anybody. If you ever see anything like this, if you're like, oh wow, that would be useful right there for like, you know, if ISOBU, if you needed to use this, one, it's already up in the Discord in our Ansible code section, and two, I would send it, you know, if anybody needed, I would repost it up. So like I tell you guys all the time, and anything I have here is available for you guys, and the reason I do that is because I want you guys to know, like if I go node exporter, and I think this has a fantastically bad search function. But yeah, here's the code. You could jump to that exact line. Should be up in Ansible code. Yeah, and there's that deployer. I said that I reviewed this on stream the other day. I don't think I'd shared it in a while. There it is right there. So if anybody needs this, anything I have is there for you guys to use, because I strip out anything that's specific to any businesses I work with. I build almost everything in my home lab first before I take it to work anyways. So node exporter works like that. I've got a Telegraph agent that does the same thing. And then I have labs that show you how to build all of them up on Killer Coda, right? So some of you guys have been around, but we've got a little labs thing here. And then Killer Coda is here. It's free. It's one of the best free things to get your hands on the system. I'm going to put it over on the YouTube side as well. And this is kind of what it looks like for people that have never been in a Killer Coda environment. It just kind of stands up. That's information about me. You come to the Linux labs, and then this is down in the Linux labs section, right? Come down here, and it's Grafana, Grafana, and Grafana. It's these three labs here, and we have a whole YouTube video on just these things. So if people are interested in that, you can do that. But right now we're working on arithmetic. There's some binary operations. The order of those operations are here. This is the order that those things are evaluated. and it's always overridden by parentheses. So if you need to override any mathematical operation, you always just enclose it in parentheses. Which, by the way, any of you guys that do computer science, you probably know this. It's very much best practice, anyways. Do the operations you want explicitly the way that you want, and don't let the system guess, because it's almost never going to be what you want. All right. So we got that. That's pretty straightforward for most of us, I think. And this is just going to be a matter of practicing and that kind of stuff. Oh, you know what? Speaking of, I wanted to check one other thing. I wanted to do this one. So sum by CPU rate mode times 100. So I didn't do this one earlier. So I want to actually do this this one. So in my Prometheus instance, I'm going to come over here. And I've got almost all of this, but let's see if we can copy this and steal it from ourselves. So sum by CPU, and we'll do a rate. And then we'll do node CPU seconds total, right? And then we'll say when mode is not equal to idle. That's fine. And then we'll say every 5 minutes, square, close that up, and then we'll say times 100, right? Yeah, so close that up, times 100. Yeah, let's see what this does. This should give us some something. So, take that off. It's as a percentage, and if you do it as this, you can deal with that percentage as a I guess it's still a float, but you can deal with it as a full number, not as a dealing with a percentage. So like if you wanted to share that and present that to somebody, that's actually the percentage there. All right. 17.82% or 17.83% as opposed to having it as a decimal number, right? I don't know if that distinction is lost on some people, but it matters when you go to present the information back, especially depending on who you want to show it to. All right. In the dimensions, I meant to say you can get all the labels by just calling for the sum. You can exclude some labels by saying without them explicitly, and it would give you all the remaining ones. Or if you had application instance and group and you called just application and group, you are being explicit about what you want, and you are being implicit about what you don't want, which is instance. So in this case, you're being explicit about what you don't want, and you're implying that you want group and application. But here you're saying, I want these, to the exclusion of instance. These both do the same thing right here, but it's just how do you want to read it, right? So as engineers, you got to think about somebody's coming after you, right? And you might say, well, I don't care about that guy after me. Sometimes it's you. I come back later, like months or years later after touching something that I haven't touched in a long time as a system, and I'm like, oh, who the hell did this? And then it's got my name on it, and I'm just like, oh, I wish I had documented this better. So as Salty Catfish likes to say, who's one of the members of our community that codes professionally, he's one of our professional coders, he often says, you're writing code for other people. You're writing the comments in there, and you're writing the code for somebody else to be able to come and maintain one day, So it's something to think about. All right. We got that done. And then there's histograms. So histograms, if you've never looked at a histogram is just the observable outcomes of a thing, right? And this one happens to be the percentage of population aged 65 and older in a bunch of different countries. They've stripped out the country information, and they've just done the number of countries. So as they look, here's the percentage across the bottom, and there's an extreme outlier of 53% of people in one country are age 65 and older. That's a severe outlier over here. But over here, we've got what kind of starts to look as like a normal distribution. There's normal distributions. There's what is it? Is it bimodal or binomial? I always forget how to say that. But when we have distributions that don't follow a standard curve, and then from anything that we can standardize over time, given enough data points to a normal curve, we can start to do our standard deviations from a mean, and we can start to do all of our Six Sigma processing around how many standards of deviations we get from the mean and what most of our values fall into. We can start to define upper and lower control limits on things. This is all process engineering stuff, but it's stuff that you don't have until you have visibility into a process, right? Like, how do you know the average time that your web server took to respond to a request if you don't have some kind of visibility into it? So visibility is the kind of key of all this stuff. All of this stuff feeds into and comes from it. So histograms are part of that. You can generate histograms inside of this, and you can look at data as a histogram. All right. So histograms in Prometheus, there are library supports for histograms that must be configured for it to work. If we go back over to our Prometheus instance here, and then we come look at our operations, we should be able to look in our functions, and down here we can look at histogram averages of things. So see how this says histogram average, but this function only acts on native histograms, meaning that the client has to be feeding that histogram data out. So let's go look at clients real quick. Clients come up a little bit in the talk, but let me pull up our clients real quick so that we can. Here's our client library. So in our client libraries, here's the client libraries that are supported. Here's unofficial third-party ones. I think you'd have a hard time finding something relevant or modern that doesn't fit into one of these, right? Into one of these client libraries. So then how you implement these is when you're writing your application or code or whatever, you go install Prometheus Client. And where do they have this? Hold on. Here's their documentation for it. They're just spinning me in circles. They're just spinning me in circles. Hold on. I was on this the other day. Where do they have this? I don't see it there. Hold on. But anyways, the point is you'd install that and then you'd run that inside of your application and feed out data that you thought was relevant. Let's go to pushing metrics from a client. Well, I need to get better on the push gateway stuff. We'll get to that here in a little bit. Back to our client libraries. Python's the one I'm used to using, but let's go look at one of these other ones like Go. Since this is written in Go anyways, Go client library for Prometheus, and let's see if they've got a good write-up. All right, we see the branches. That's fine. I want to see if they have. Oh, I know the Python one has it somewhere. But anyways, the point is you can feed out data as either histograms or graphs or as instant values. We got them up here. Here's all the things that you can feed data out as right here. It can be a counter, a gauge, a histogram, or a summary. Those are the 4 metric types that you're typically going to be feeding out of: counter, gauge, histograms, and summaries. So when we look at that document that we just saw where you could average histograms, if the data is not natively in a histogram, it's not going to be, you're not going to be able to function with it. You're not going to be able to do those functions on it, rather. All right, so anyways, so we're down here. We were on binary. Okay, we did that. Histograms. Okay. And then from that, you can do AppDeck scores, which will, there'll be a method for counting observations falling into certain buckets. An important thing about the AppDeck score is it has to be done again against a already created histogram. So we do have to run this against histograms. But if you wanted to count up, in this case, the HTTP request duration in seconds bucket that you've created, and you want to see anything that's less than or equal to 300 milliseconds, right, over 5 minutes, and then you're going to divide that by all of the second durations count. So all the things that you have divided by the number of them that fall under the 300 milliseconds, that'll show you right there how many things you have that are failing. In this case, they're falling into a certain bucket, but maybe, or sorry, those are the ones that maybe succeed because they're less than the 300 milliseconds in that case, right? But then if you wanted to, so yes, it shows all the requests that were under 300 milliseconds in the histogram of that. But here's the thing about this. This is useful, but when you want to do statistical characteristics of a thing, you might say, well, I just want to know if over the 95th percentile, as we say it, we can see, the histogram quantile here. But again, you can only do histogram quantile if we are statistically looking at things that are already in histograms, right? So it has to be already in a histogram for you to do a function of a histogram quantile. Otherwise, it's not going to work. So, all right. So that's an important thing. Timestamp metrics. We can pull timestamp metrics around things, but this right here is not super useful because that's an epoch time, right? Everybody knows epoch time is midnight on January 1st of 1970, right? It's the Unix day, as we like to call it. So that's epoch time. That's okay, but that's not going to be super useful for most of us. So timestamps are given an epoch and can be queried by any instance vector. So I can see when this was last queried is what that's showing me. All right. All right. If you want to see time since, you might do something like this, which if we pull this up here real quick, go pull this up here. Put this over here. You'll notice that I actually pulled these directly out of my Prometheus when I did this. But I'm going to come over here and I'm going to say, what is the current time, right? And you could pull this anytime and see there's our current time. And then I want to see our time minus the timestamp of any value. In this case, we're doing go memstats freeze total. Oops. Right? And then if we query that, that's when they were last ran from any job. Does that make sense? So we can see the information. We can also, again, go grab them by, if we just want the infra or we just want the dungeon ones, we would just come in here and we would then limit it down, right? We would say team equals infra. Whoops. And then we can do that. It'll give us just that. We can say team is infra. I think we can put or in here. Let's see if that works. I'm not sure if that'll work with an or. No, that's fine. If that doesn't work, you can query it by just adding more, right? But you can also over here say it's like infra, right? And then that should be able to. Yeah, we need an X. There we go. But why is it not sure why that isn't working as a query. The query should work. The query with that should work as well. Whoops. That should work as well. All right, well, it's fine. I'll have to get better with the queries, but that's how you do them. All right. So that's timestamps. You can pull timestamps and you can see when things were last scraped. And Prometheus also has a value for anything that it's looking at, any instance of whether or not it's up or down. And it does that evaluation based on when the last scrape happened and if it was successful or not. All right. So digging deeper. I said deep hole. Digging deeper, right? There's our digging deeper. I have those for each section. I need to add to some of those. But let's talk about instrumentation and exporters. So we'll get into some of that stuff I was trying to show you guys. Client libraries, instrumentation, exporters, and structuring and naming metrics, right? So here's our client libraries. They can expose common metric types. Those are the ones we were just looking at: summaries, graphs, histograms, and the counters, right? So we can count data up. And then there's unofficial third-party ones, but they cover most anything. And then if you don't like any of those, you can also use exposition formats to expose your own anything you want to Prometheus, and Prometheus will come along and scrape it. All right, so that's definitely possible to do as well. So instrumentation, these are best practices. So instrument everything. Every library, subsystem, and service should have at least a few metrics to give you a rough idea of how it's performing. There's 3 types of services. Typically, there's online serving systems, so things that humans expect to interact with and get responses back. These are like web pages and responsiveness of like front-end applications that users touch, that kind of stuff. There's offline stuff. Nobody's actively waiting for a response, but maybe, servers are spinning up or something like that in the background. But you still want to track those things. The more you see them, the more you can up their performance. And then there's batch jobs, which are offline processing done in batch jobs. But batch jobs are distinguished by the fact that they do not run continuously. So batch jobs turn on and off as they're needed. We sometimes do these out in like AWS as what we call spot instances. So we spin up a node or set of nodes only when we need them late at night, and then we turn them off. And typically we save a lot of money because with spot instances, you can save like 70 to 90% of the value of an on-demand type instance, right? So it can be really valuable to you to run batch jobs. But the problem is it's very difficult to scrape those because how well are they doing? Who knows? Who knows how well they're doing? They're off, 90% of the day. So there you go. Okay. Subsystems, they exist as part of services, obviously, right? Oh, Hack the Planet's on the way over. Hey, how's it going, Hack the Planet? We are working on Prometheus, specifically getting ready for the certificate for people that want to get better and get those kind of things. And, not everybody wants to go get the PCA. Even though it is on sale right now, it's only $175 instead of $200 from the Linux Foundation. But some people just want to know how to use the tool better. So I'm just kind of walking through a type of tool that I use a lot for monitoring systems. And for you guys that just got here, this is the home lab monitoring setup that I have. Node exporter exposes metrics, and then Prometheus comes and pulls those metrics from it and feeds it over to Grafana. My home lab monitoring kind of looks like this, depending on, what part of the day you're looking at stuff. That one's terrible. I don't normally show that one. This one is more of like my home lab stuff. And then maybe something like, where's my security one? Security's pretty all right. So this is home lab status, security status of systems, those kind of things, right? I can see what's going on. We can see how Ranger's doing. Ranger dog downstairs. Anyway, so that's what we're working on. And we were down here. Subsystems exist as part of service. Libraries, no additional configuration from users should ever be needed for libraries. That's an important thing. But what do you track out of libraries? Query count, errors, latency of calling outside resources. Like how long does it take to get there? GitLab CE with Podman. Nice. Nice Hack the Planet. That sounds fun. Sounds like a good little thing to practice. I am kind of chilling today. I don't have my camera on because I didn't want to move all my green screen stuff around and just kind of that. So I'm just kind of hanging out today, and it's it's a chill day. It's a day off for most people. It's a federal holiday for most people. So all right, so we're still working on this. Logging, as a general rule, every line of logging code should increment a counter somewhere. So that's a really, I like that. I hadn't read that until I was studying for this, but it's the idea that if you are sending log messages, and those log messages are being either local or up to something like Loki, or even out to some kind of syslog or graylog or whatever you're doing, every time you send a log message, you should increment a counter. And I think that's a good plan, right? Like now you've got back to logging. What is logging? Logging is immutable mutable events that you can't change. You know, the event happened. There's a perfect record of it happening, and you then take that and use that in whatever way you want. Some people like to change logs around after they're created, but that's fine for you to transform information out of a log and make it more useful. But the original log message should never be changed. That's a very important system engineering practice. Don't go changing things that are already good. You know, that it happened. If it didn't happen the way that you expect, or if you didn't capture the logging right, go rewrite your logging tool. But don't go changing it and mutating it before it lands somewhere. The event itself is an immutable action, an immutable event. All right, failures should increment counters. Thread pools, you can track the query, number of threads in use, number of total threads. It's important. Caches are one of the hardest things for people to implement on the coding side of things, right? Track how many queries there were, how many hits and misses, and then the overall latency of the caching tool. Collectors, export gauge to show how long the collection took in seconds. So we were talking about gauges. Collectors should have a gauge for how long collection took, right? All right, exporters. There are hundreds of libraries already set up for exposing metrics. There are all the default ports. You don't need to memorize these. Whoops. You don't need to memorize these. But here are the default ports. 9090, that's Prometheus server. 9091 is the push gateway. I've never pushed anything to push gateway, so I'm going to have to play with it. But down here, node exporter, 9100. Those are the most common ones you're going to run into. 9090 and 9100. But look at all these other exporters that are part of Prometheus. These are registered exporters. AWS Instance Health Exporter, 9165. That's what you would scrape. Lustre is a very big high-performance compute storage backend. They've got their own exporter. Maybe I want to go read about it, right? It's all the data that we can be pulling out of Lustre. Let's see if there's a... I know there's a GPFS one. Let's go see. But GPFS is not official, apparently. Yep. Because global GPFS would be... Oh, actually, maybe... Nope. The global, or GPFS, which is General Parallel File System, is not there. But there's a whole bunch of them. NRPE. Man, I haven't seen NRPE in a long time. That's a Nagios thing. It'd be funny if you're running Nagios in an environment and then you're using NRP. So you're using Nagios and then you're using NRPE and feeding over to Prometheus to track your Nagios. Because Nagios is itself its own monitoring solution, right? Yeah, there it is right there, Nagios. Boom, look at that. Yeah, man. Yeah, that's Nagios Remote Procedure Execution Daemon, right? That's clever. So, man, that's a throwback to something I haven't done in a long time in the industry. I used to write those. I used to write things that would go run on my Nagios nodes, my Nagios, in my environment. I would go and run Nagios and check things in my... And actually, one of the engineers was just telling me the other day, one of the guys who used to work with me, I left that project 11 years ago, and he said they're still running the Nagios that I built for it. So I think that's pretty funny. Kritzy, what do you want to see? Oh, you want to see the other thing on the Podman? Yeah, Hack the Planet, if you're still around, I don't know if you mind linking that. If you can't link it, I guess you can just whisper it to me. Or people can drop it down in the Discord as well. What's going on here? All right. By the way, you guys are welcome to hang out down in the Discord. We got a little bot that'll introduce you and say hi to everybody and all that good stuff. So there's that. Oh, Kritzy, did you need the one that I was on? Did you need the NRPE one? Are you using Nagios? I could pull it up. Yeah, hold on. Oh, it's from Canonical. Oh, wow, okay. Yeah, here it is. Yeah. I'll link that on both sides for you guys. There you go. Yeah, so if you guys have ever heard of NRPE, yeah, it's a Nagio Remote procedure execution. Man, I haven't written something for that in a long ass time. Like 11 plus years, but that stuff's still being used, so that kind of feels good. One of the guys that came and talked to us the other day just told me about that again, because he's now a director for his company. He's a director of engineering, but he still gets his hands on stuff and that kind of stuff. So you want to follow a best practice if you're writing your own exporter, specifically around metric names and formats and labels. Let's see, there's a Blackbox idea and using multi-target exporters. And the reason I linked this was because this has how you can stand up your own little Blackbox exporter and just run it in Docker. So if you guys are Docker people, run it in Docker, and then you can have it listen, and then you can just go do queries against it and look at what kind of information's coming out of it, right? Give you all kinds of information about how the system is running and all that kind of stuff. All right, thanks for the follow. Is it Ayush? Hopefully it's useful to you. We are doing system stuff, and Prometheus.io and modularly that you can query individual things if you want out of this little black box tester. That's kind of cool. Gives you some stuff to play with in the black box YAML. All right, so I haven't played with that, but that's kind of a cool little thing. It looks like to bounce queries off of out of the system. Looks like you can stand up a lot of different stuff to play with in there. So that's good. That's fun. That's fun to have a tool that we can hit stuff with, right? Also, I haven't linked it in a while, so there's the Discord, and I'll put it over on the YouTube side as well. You guys are always welcome to hang out down in there, talk shop, engineers, architects, all that good stuff. All right, structuring and naming metrics. Metrics must comply with the data model for valid characters. That's important. There's a data model. You have to have that as a minimum. So they should have a single word application prefix. Sometimes people like to call this a namespace. So Prometheus notification total, HTTP request. So when I'm looking at my actual tool here, right? And I start to do my Prometheus queries, I can come up here and I can say Prometheus, and Prometheus will try to be smart for me and tell me all of these things that fall into that same application prefix. You see that? So if I want to see, is Prometheus ready? I do a query. Boom. 1. 1 is analogous to true, or yes, or up, right? In the systems world. So it's up. Prometheus is ready. Which also is good, because if Prometheus wasn't ready, well, this thing wouldn't be responding, right? But that's the point, is that's how you start the naming of your metrics. Something like that. And then I can go see a whole bunch of different information about it. I can see a counter of all the requests for the last 5 minutes. They've only come from me, by the way. But I was hitting the button a bunch earlier, so maybe I'll see, here's my 200 codes, so things that came back well, 200, 200. Maybe I just want to see not code 200. So code 200 is all my good stuff, but I want to see all the bad stuff. So I come in here and I say code is not equal to 200, right? Let me close that out, and then I should be able to execute that, and it'll only give me my other codes. And maybe for all that time, I just want to have a number, right? Just give me a number, right? Just count them for me. Just sum them all up. Oh, whoops. What? I don't know. Let's say, maybe that one will work. Whatever, I don't know. The point is, struggle with integrating Prometheus monitors on K8s. Is it a use? That can be a problem, struggling with integrating Prometheus monitors on K8s. Thankfully, there's some good tools out there. What if I go here? I can do it this way, I guess. I can just do rate. But this will give me the... What? Hold on. It would help, guys, if I did it around the the thing right. There we go. There's the rate. But really, I wanted the sum of all of them. I wanted all of them in that time, right? But sum by, I don't know. Let's try sum by count. Whatever. Screw it. I don't know how to do my queries. I need to learn how to do that better. Use the Helm Prometheus stack. Yeah. Yeah. There's no reason to recreate everything. I would definitely use things that are already built. Yeah. Yeah, is it a use when I get a lot of options on something, kind of like what Kritzy just mentioned, I will do the bare minimum to get the thing working, and then once it's working, I will turn things on and off and test, like a rapid spinning through my deployment to see what I need and what I can do without, and then I will get what's called like a minimal viable product up, MVP, minimum viable product, and I do that a lot. Minimum viable product, not violet old. What the fuck? Stupid ass closed captioning. All right, must have a single unit. Make sure you're using the base units correctly. Don't be mixing them. Suffix value should be the unit of measure, so seconds or totals or whatever. Should represent the same logical thing being measured across all label definitions. Keep the same measurement the whole time, and base units are very well defined. So let's go look at our base units here. Here's our base units. Time should be seconds. Temperature should be Celsius. That is a standard that was put together, right? Whether I like Celsius or not, I'm very used to using Fahrenheit, but Celsius is a very technical type of thing, right? So like it's a scientific measure. It's used globally, and it's perfectly acceptable for tracking, right? Length, bytes, bits, all these things should be having a base unit. So here's this one. Always use bytes even when bits appear more common. Now, people might say, well, where would bits be used? Do we have any network engineers here? Don't we, as network engineers, always deal in bits? We're always talking about the bits per second, right? We're very rarely talking about the bytes per second. But even then, we're trying to aggregate and keep things on the same thing, so we use bytes, all right? There you go. All right, good. Let's go back over here. Digging deeper, instrumentation, best practices when writing exporters. Writing exporters, maintainability and purity. Make sure that you use the best practices of naming, right? These are the same things that I was just talking about. Have an application name at the beginning and then have the proper measure at the end. And they explain with it. Valid metric names must fall into these groupings. You can use underscores. You can't use dashes. Morrison said, do some of these monitoring aspects help in achieving NIST requirements? Not in my experience, Morrison. My NIST experience all tends to... Well, I mean, I guess it depends what you're doing. But for me, like, my NIST standards tend to be like my compliance of like a build... Like when I build my systems, I don't do any other real compliance with NIST as far as that goes, I guess. So I don't think these directly help with that, but they might check a box somewhere, because understanding what's going on in the system, this helps a lot in troubleshooting, and it helps a lot in capacity management. Like knowing where the system is and where it's growing to, how it's grown over the last X amount of months or years. Very, very useful for us as engineers and planners and architects and all that kind of stuff. Helps us to find bottlenecks. Helps us to find what some people call the long pole in the tent. What's taken the longest time to come up, or what's taken where do we need to focus our key performance indicators and our service level indicators? Where do we need to focus and make sure that we're not breaching service level agreements and those kind of things? But for straight security requirements, I wouldn't say that I've ever seen like a box that we had to check that Prometheus would fix for us, if that makes sense. Hopefully that's clear as mud. Right? All right, so he's digging deeper. Yeah, keep it clean. All right, so let's go to alerting and dashboarding. This is definitely going to be one of the things that I'm the weakest on. Dashboarding basics, I think I'm pretty good on dashboards, but the configuring the alert manager I've never done. So I need to start doing it in my home lab. So I need to start playing with that a little bit and keeping that clean, right? All right, so anyways, so dashboarding. Prometheus Guide to Dashboarding. Have no more than 5 graphs on a console. So don't show people too much. And I agree that there is too much data. Sometimes I see these really cool looking, very colorful dashboards. And if I notice it's colorful, being colorblind, then I know that it's way over the top for most people. But sometimes they're trying to do all the things on one dashboard. And that's not a great thing, like, because your brain can only process so much, right? So no more than 5 graphs. Have no more than 5 plots, like lines on any one graph. You can get away with more if it's a stacked area graph and it's like very obvious that these are all these things together. But if you have more than that, it's very difficult for people to distinguish or read, and your visualization starts to become noise. Visualizations becoming noise are things that very quickly get ignored and become irrelevant to the company. And that's a bad spot to be in as like an engineer, and that's a bad spot to be in like in trying to keep your stuff running. And like I have a security operations center or a network operations center. Both of those are people that sit around all the time and watch systems for me. And if I give them stuff that's unusable for them to be able to alert on, or it causes them to alert all the time, then that's not good. Because if my system's alerting all the time, I need to go fix my system. There's something dramatically wrong. And then if my system is alerting but people can't catch it because there's too much crap on the dashboard, that's also a problem. So it's one of these things where it's like, you know, don't overdo it. You know, anything too much. How do you overload a sensor? You jam it by giving it too many signals, right? So it says when provided, console template examples, avoid more than 20 to 30 entries in the right side table. Fire alarm keeps going off by error. You start to ignore it. Not good when the real fire starts. True. Yeah. Alerts that continue to alert get ignored, and ignored alerts might as well not exist. You might as well just go turn them off. They even mentioned that in one of the practice test questions I saw. It was like, hey, what's a bad use of this? And the right answer was, don't just snooze alerts that you're tired of seeing, or snoozing alerts that aren't needed anymore. You need to go remove them from the alert manager. If things aren't ever going to be relevant again, then you need to take them out of there. There's no reason to have it in the background with like just a little check engine light always on, right? It says if you find yourself exceeding or violating these, you should think about breaking down subsystems and graphing aggregated data instead of broken down data. So when we say aggregated data, what that means is if you're doing this and you're getting too many plots and too many graphs, then maybe instead of looking at all 1,200 nodes in your system, you need to aggregate it all together and show it as one line. And then if that line moves up, then there's something. And then maybe, like me, I have dashboards that are specifically for watching how the system is performing overall, and that's aggregated. And then when we troubleshoot, I'm over there looking at broken down data by node, right? How is the individual node doing? Well, how the individual node is doing is irrelevant if everything's moving along. But if things are starting to be sluggish or things are not working the way that we want, then we do need to go look at why some of those nodes are out, right? Breakdown console dashboards based on purpose. Are they for different use cases? Yeah, I don't want everybody to see all of my dashboards. I have dashboards that are very much like my dirty laundry in a system. Like I have dashboards that show that I have 40 nodes down in the cluster. I don't want people outside the cluster knowing that. They can just see a roll up that like 6% of the cluster is down on any given day. They don't need to see how many nodes it is. That's terrible looking, right? So, you know, these are the kind of things that we might want to do. And we've gotten that down to only 15 nodes down at any given time. So that's actually a pretty good fix and that kind of stuff. All right. Configuring alerting rules. This is something I am not good at. So we're going to go look at this inside of the system. But alerting rules allow you to define alert conditions based on Prometheus expression language and fire alerts to an external service. Good. So we can set up, looks like these groups. name example rules, and then everything here is YAML, so it's underneath. Learning rules are configured the same way as recording rules. That's good. Recording rules are rules that you can use to aggregate data into new buckets. So if you have like processor intensive things that you want to do and basically just use that processing time when what might have otherwise just been normal CPU cycle, 15 is irrelevant, percentage is relevant. True. Yeah, and when you look at our system, when I came on the system, we averaged about 8% of the nodes down out of a 1260 node cluster, 1211 compute. And then now it's 1200, you dumb computer. Anyways, so yeah, 15 as a number doesn't really mean anything, but percentage. We went from 8% down to like 1.5%. And that starts to look like a lot better, right? Yeah. And it's because we started looking at our systems every day, right? It's one of my visibility concepts is touch all your systems every day and get like a visible report. It's the same thing we did in the Army. We did these things called green to green reports. Anytime you moved as an infantry person, when you got done, since you carried all of your important gear on you, you touched every piece of your gear, and then you looked at your team leader or squad leader and said, yeah, I got all my stuff still. And if you didn't, then, you know, you would say, no, somewhere in the last movement, we lost my stuff. And then you would have to go find it or whatever, right? Like, that's kind of a thing. You even do that in combat. It's a real thing, right? You always, but it's the same thing with our system. So let's go look at this. Let's go here, and we're going to get out of red node. Let's get into our Prometheus node. This was us messing around the other day. Man, what's going on here? I was doing all kinds of crap in here. All right, let's go to Prometheus. Go to Prometheus. What's going on in here? Here's our alert manager. I've got no triggering statistics in here. I got nothing going on in here. But I have it, right? Recording rules are set up to generate computationally expressive expressions and then save the results in a new set of time series data, just so you have it. Learning rules are generated via templates and can include metrics and labels. I have nothing going on in my alert manager. OT, but you're on FA policy D and prod. I have not run FA policy D and prod Q. No. I don't even know what that is. Let's go look at that. I don't even know what this is. Concept of trust, an application trusted when it's installed by system. Okay. I've never played with this, no. No, this looks interesting though. You can trust file. This might actually be useful in our this might be useful in our high performance compute to keep you from doing ratchet shit, especially on our login nodes. I like that. So it's just got it's a policy of things that we're going to trust or not for applications. Anything that comes in through an RPM database is allowed, it looks like. But anything else that gets added, yeah, Q, that would be awesome, man. This is super useful. In fact, I'm going to grab that. That is a security hardening tool, so I'm going to put that in down here and say. But yeah, if you have any cool stuff around it, topics from stream. Boom. And I always get rid of the embeds because I hate embeds. They're super annoying. Okay. So that's a pretty cool little thing. I haven't played with that. But I imagine turning that on inside of a production system would be, it's compared to App Locker. Okay. From Windows frequently permit by exception policy. Nice. Q, and from what I read, it says, yeah, it breaks everything, especially breaks any third-party stuff. But it said right there that anything added by RPM works, so should be allowed, right? So that's interesting. That's an interesting little behavior that we might go look at. So, okay, so we've got some information here about how you should write exporters if you're going to write them. But guys, there's literally like 100 plus exporters and metrics and stuff that are out there for you to use and look at. So You don't have to think about writing your own unless that's something you're really, really planning on doing. Like that's something, maybe a stretched assignment or a stretched goal that you have. All right, so I don't have any alerts up, but I do want to write some alerts in my environment. And then the thing about the alerts is they can push to email. They can push to, so in our alert manager, we put command line flags in config file. We're going to route where to send the alerts, if we're going to aggregate them, if we're going to throttle them, or if we're going to mute them. Then there's inhibition settings. So inhibition settings are like, if something else is related to this that's down, I don't have to alert for all the other 30 matchers. So like if one system's down in a network that's far away and the other 29 systems are also down, well, I don't need to alert on all 30 of them because it's most likely that there's a network error, right? There's a network connection issue, and there's no reason to be alerting on a bunch of servers that out of band I can go hit and they're up. It's just the connection to them that's down. So I do want to know that that's down. I just don't want to necessarily have, I don't need to have 30 alerts to get that there. Label matchers, alerts to route, silencers, and inhibition rules they can come from label matching. SK, that's fine. I was on a little earlier than normal because I just wanted to kind of hit some high points around this Prometheus PCA stuff, kind of clean it out. I've been taking notes of things that I need to do better. This was from the other day, but I need to add some pieces to this. One of the things I need to add here is, that's fine. I don't need to add anything to that, but there's an AM tool that can lint this for you. So if you guys have ever worked in any kind of YAML, YAML can be very, very frustrating. If something's busted, you find out when it just breaks, right? Or you find out when something. So anytime you can use a linter looks through a block of code or an execution of syntax and says, yeah, that looks good. From a syntax standpoint, this will feed into the system. But linters are very useful for finding, like if you don't have a properly indented line, or you have something add an incorrect indent so it's not being seen as like a new stanza or something like that. So linters are super useful in all kinds of different types of coding, but I find them really useful in my line of work around like Ansible and anything that touches YAML, because you can just have hidden stuff that just gives you a hard time, or something indented incorrectly, and it's just... So AM tool is a linter tool that can help you out a little bit. And then alerting basics, what do we want to alert on, right? Alerting must be done in camel case, so you must write your alerting in camel case. They have decided that as a community of Prometheus engineers. I came to it later, but this is part of the rules, and the rules must be followed. So your alerting must be done in camel case. That was decided, and there you go. Oh yeah, I'm not surprised for YAML. 63 possible ways to write multi-line strings. I just know of the exclamation mark in front of it, or not an exclamation mark, a pipe in front of it. That's the way that I do it. That's not surprising though at all. Severity should be used a label called severity with one of the following values. Critical should be routed immediately. Warning can be routed, but it's just kind of like a warning. It's not worth like alerting out to something. And then info is not routed, but you go and you see them later when you troubleshoot. So I really like that level of description around what the warnings are. And then alerts should have the following annotations. There's a summary, which is mandatory. It's a readable version of the alert name. And it's funny, when I was looking at summaries, if a summary was written for node file system almost out of files, it would basically be that as a sentence. But it just doesn't have the camel case because it's just a string. And the description is mandatory, but it's more detailed for a single alert with the most important information templated in. So the description can be, node file system almost out of files, but node would be templated as the name of the node. And you can feed in the name of the node as you actually send it out. And then it would say like P01 Jump 01 server is jacked up and needs whatever. And, it's at 79% of its, or 85% of its file space. And then, it'll alert me with that. And it'll give me numbers in there of whatever I want templated in. Templates are super valuable. You just have it sitting there, and then you feed in information for whatever the alert or whatever the thing is, right? So that's super useful. All right, digging deeper, Alert Manager configuration files. This is one of the things that we were just kind of looking at, but there's generic placeholders in there. There's a global, right? There's a global setting here. I'll move this over here to the left so we can look at this here. And I'm going to pull up mine here. And here's my Alert Manager right here. So my alerting config. And then I can come down here and I can go look at, there's global. Templates, route, receivers, inhibition rules, any of those kind of things. Route related settings. Route is going to be where we're going to send things. And any labels or any of those kind of things that we're like. Yeah, templates are templates. It'll be a little bit different than Jinja since Jinja is based on Python and this is based on Go. But other than that, it's pretty similar. Hey, Robodom showed up. There's our Discord. Over on the YouTube side, Abdo asked, "Can I do RHCSA practice labs?" We have some of those down in the Discord, but strictly speaking, even though I do almost 100% of the time work professionally inside of Red Hat, I don't really do like any of the Red Hat certs. So, Abdo, we have a lot of people that are working on them or have passed them, but I don't strictly speaking do anything with them or have any labs around them. I could set up like Rocky Linux and we could do real close to it, but I don't have any actual Red Hat in my environment. Okay, so where are we at? Now we also had... So there's nothing there. There's nothing for Alert Manager itself. Alert Manager has its own. We'll look at our Prometheus. We'll call him Prometheus. Got all those pieces. I don't know why my Prometheus is disabled. Make sure that that's alerted and set up. There's our Alert Manager config. So it is all in here for as far as my Alert Manager goes. But I don't have anything set up in here. So I'd have to go set some of this up and pull some of these pieces in. Let's go do something here. Let's go look at our Prometheus.yaml. Let's come here. Let's turn this on. Let's see what happens if we just turn this guy on. Boom. Alert Manager 9093. System CTL. Status. Prometheus. It's up. Restart. Okay, status is it's up, and let's do a ss-ntulp grep-i for alert. There was no alert earlier. 9093, still nothing. So we got that. No 9093, huh? All right, probably because there's nothing in there. But I need to get in there. I need to build some of these and practice this. SS is it is the future version, or it is a moved forward version of netstat. So SS, it is another utility to investigate sockets. But netstat isn't on all modern Ubuntu and Debian versions by default, so SS is kind of the way that you do it instead. I think there's a little bit of subscription manager topics. That's the only thing you miss out on the rel derivative. Yeah, that's probably true. Q. Yeah. So SS can do a lot of the stuff, and then you can go read about the useful things. I always do it like this. So I do ss-ntulp, and what it'll do is it'll give me the listening port here. And then in this case, I only have 9090 and 9100. I expected 9093 to be on because that is the listening port for Alert Manager. And I would have thought that Alert Manager would have been at least here. That's fine. We'll play with that later. Tune all like tuna. I like it. Tune app. Okay, fair. Yeah, and the main thing is you know why you do it, right? Everybody's going to have different ways that they do their SS or their netstat, but just know why you want to look at things. One of the things with the P is it's going to force it to not show me. Where's it at? Ah, well. Oops. It's going to force it to not try to give me... If you don't have that P on there for port, it'll try to tell you SSH here. So watch this. Or, oh, maybe it's if you don't do network number. Yeah, see how it tried to resolve these? I don't want it to resolve them. I want to see it as a hard port number for myself. Not everybody likes that. PS flags, people want to know PS flags. Mine are PS-EF. I use PS-EF. There's AUX, There's all kinds of other ones. I've always been a -EF guy because I can get everything I need. And also one that I really like is I can do EO. And then over here with O, I can do like lstart, CMD, and I will get, and then maybe we can do UID as well. So now that would give me the name. So it'd be lstart. That's the exact time that it was started. There's the command that called it. And then in this case, the user ID. And there may be... And then if you ever need them, if you ever run out or you need... So you just man PS. And then you say... option. Look at all these different examples of ways that you can call PS if you want. But for me, where are they at? Process selection by list. Where's the -O? -O will give you format, and then here's the format things that you can call. Those are some of them. They're not all of them. Here's some of them. Those are old sort keys that you could use. Yeah, so look at this. Here's, for example, PS-EO. I want the process ID, the user, and the args. And then I want to sort by user. And then here's all the codes that you can use here. Massive amount of codes that you can pull into this if you wanted to. LSOF is great as well. But with the EO, you can do name. And then, whoops. Thought name was one of those. Oh, it's user. Boom, there we go. And then we would see that it's root or Prometheus or whatever. Whatever the different things are on the different stuff. Oh wow, Abdo, you're an intern at Red Hat. That's awesome. Yeah, if they'll give you the free access to their lab environment, you should absolutely go in there. Here's some good. There's a philosophy of alerting from Google, and that's one of their docs. And then there's alerting info, and there's some good alerting stuff in there. And then down here, I have just a bunch of other things that I think are useful. There's this training. The training is actually in my thing here. And Prom Labs, they put together this training, and you can just go through and read a whole bunch of things they've tested on this, and then they talk about what is Prometheus, and they give you some good experience and pieces of it, right, to go look at. Give you some good, like, they give you rate, node, CPU, seconds total, mode is not equal to idle in 5 minutes. That's very similar to one of the rates that we did earlier. And then you can look at that in a graph mode instead of a table mode, maybe so you can see what your different systems have been doing. Here's it's the same instance, but this is its different CPUs right here, actually. And actually, I take it back. This is its CPU, but it's all of the different states, but not the idle one. So they got rid of the idle one, right? But only for one instance in this case, because they're probably just going against themselves, right? The slides themselves are going to be on our Discord soon. We've got Discord out there. I've got a bunch of data out there around this, and I've been putting this together. But then I always put things down into presentations when they're ready. So we've got our different presentations up there from when I do this stuff. I got a little bit more to make this look the way I want it to before I put it up there. But yeah, they've got all these different pieces. Look, Prometheus is not great at logging or tracing. That's not really what it does. But it does really good with time series. You can use it to do some of this other stuff, but it's not really designed to be logging. You typically want to use a tool like Loki instead. L-O-K-I. Loki is like, it's just the standard for that as far as I'm concerned. And if you guys have seen that in my home lab, that looks like this. Here in my lab environment, right? Loki is like this logs app stuff. So you come over here, and here's all the people trying to log into my system and get into my exposed port 22 out to the world for the last 6 hours. These are all the login attempts. That's probably about 200. Probably just under 200 right there. Yeah, it's probably, well, that's maybe like 160. Yeah, probably closer to that. But still, that's a lot. Yeah, Loki is a tool that you can just throw data at. It's an API endpoint. Yeah, Robodom, this is my home lab. Yeah, this is my P01 Jumpo 1 box. Yes. Yep. And then how's Ranger doing? That dog. Oh, that dog. And it's still light outside. It's like 7:30 here. It's almost 7:40 here, and there's still sun. For my lab setup, SK. A link for my lab setup, kind of like you're talking about like this drawing or something on my monitoring. Yeah, because I use Promtail Agent to Loki and the Grafana to feed that stuff. SK, I've been building my lab for like 7 or 8 years, so my lab is just this big hot mess. But basically everything I've ever done in there, especially the stuff that's Ansible based, is up here. So all of our Ansible code that any of us write tends to show up in here. So if you guys are just like trying to get better at systems work and you want to like see what other engineers are doing and you want to like talk shop or ask questions, we do a lot of this stuff up in here where we go and we, you know, pull data out of APIs and do stuff. There's all kinds of stuff Ansible can be used for. So this is one of the things I tell you guys, like, come in here and look at this stuff. And we have some things, like I was asking the one day, what is, you know, why would you use this one over this one? And what would be the reason? And if you're like, well, I don't see the difference there, well, then you probably need to work with Ansible more. Some of you like look at this and you go, well, this one only instantiates the package apt once and it gives it a list. This one calls it over and over again through a loop and closes it every time. And this can really degrade the system. And there's runtime errors that can happen here. And there's all kinds of other things that can be happening here. So there's reasons to use one or the other. Like some people like blocked out their answers as they were doing it. Yeah, this is all good stuff. All right. But anyways, that's where most of my lab stuff is. This stuff is up there as images and also as the Excalidraw, because then you guys can load it up yourself and do whatever you want with it. Frickin' Ranger. Let me go back here. I want to do one of my earlier things, and then I want to go look it on the graph. So, node, CPU seconds total, right? Boom. That's going to give me everything here. But then I'm going to say that I want it when the mode is not equal to idle, right? Because we don't want the idle. And then we want it for the last 5 minutes. And then if I look at that, Boom. And that's for each instance, right? Then I go to my graph. It says range vector must be scalar or instant vector. Let's run it again anyways. This is all one system. We actually want that to be rate. Let's get the rate for all those. Okay, good. That's what we want. So this will be pretty small. Yeah, RoboDom Ansible will help you no matter what you're doing. Even if you're a dev, there's a lot of, like, if you want to know, like, the most famous guy around in Ansible, it's a guy named Jeff Geerling, and he's a Drupal / Python / Ansible guy. And he writes all kinds of things. He's got a pretty successful little YouTube channel and all that kind of stuff as well. So he does a lot of good stuff there. All right. Anyway, so there's all this stuff. I have this stuff down here from earlier, hands-on practice with Killer Coda for free. If you want your own server build, so you can go do the log stuff that we were doing. If you want a Docker build, so that you can go mess around and do that stuff. All right, so hands-on practice, home lab, all these things that you can do. All right, let's see. Questions, drop them in the Discord. I have a lot. I got to add some more to this, so I won't be putting this up in the Discord just yet. I've got some more to add to this and some more kind of stuff around this. But let me answer the Ansible question here in a few minutes. But let's get this out of the way. And see if I have a tool for. Let me pull up a little talk I did on Ansible. Hold on a second. Oh, let's see. Where do I get this thing? Let me see if I have this. Oh, I got that. That's the wrong way to open that. Hold on a second. Let's open this with. Maybe Chrome? How's that look in Chrome? Yeah, that'll work. So I'll show you guys. I'll do this. I'll do this for you guys. This is a talk that I gave. Let me see. Hold on. Hold on. I thought I could snap this to the page. Let's see. Fit to page. And then just page up and page down it. Yeah, I guess we could do that. All right. I'll do this talk here, and but I'm gonna take a break real quick, and then I'll come back and we'll do this little talk. But this is a tower thing. This is Ansible, and this will answer, I think, the question around what is Ansible. What are the chances that SSI isn't all that safe? When you say SSI, what's that acronym mean? I need a little more context for that. Take an 8-minute break. I'll be right back. RoboDom, you're in charge till I get back. Oh, safe superintelligence. I haven't messed with that any. We'll see. I'll be back. All right. Let's see what's going on here. All right, so we'll take a few more minutes, but this talk is one that I gave to my company Redline a while back, and it dealt with using Ansible and specifically Tower, which is now the Ansible automation platform, or the free version AWX. And some of you guys have seen that I run that in the home lab. So we'll get to this here in the lab. Where's this at? Hold on. Did I close that other thing down? I didn't think I closed it down, but maybe I did. Let's go to my home environment for AWX, and I'll pull this up while we're talking through some of this, and you guys can see how it kind of works. And I have a pretty old version of AWX, but it works really well, so I don't change it up. So let me get my home lab up here. Yeah, the system's taking its time, but that's all right. Not a very fast box that I've got it on, so we'll talk about this here in a second. But feel free to take a break, smoke them if you got them. I don't smoke, but that's what we used to say in the Army. Hey, thanks for the follow, more or less. Hopefully this stuff's useful to you. Let's, anybody that wants to do some Ansible here, show up in the next few minutes and we'll do some of this stuff. The password Keck. Anybody know what the Keck reference is? Oh, Robodom, do they only have a senior HPC role right now? Yeah, you know, don't feel bad about that senior HPC role. Who knows what those guys are looking for? Because I am part of the company, and they had me go talk to those guys, and those guys said they didn't think I was senior, and I'm like, all right, I guess, wow. All right, well. Guess maybe hire somebody that I trained 20 years ago on these systems when you get around to it, but I don't know what they were looking for. It was amazing. But I'm also convinced some of those guys couldn't hear me or something, because they asked me about like subnet manager and how I would find a subnet manager on a node and see which one was the major or the primary, and I was like, well, I would do like SM info, and then I'd look around and I'd look at the network and see which devices were talking to whatever. Diamond, yeah, I'm a senior HPC engineer. Actually, well, I guess you can call me a principal, but yeah, that's what I do. But anyways, the subnet manager, it's for InfiniBand networks. And then the guy, after I get an answer in the question, kind of talk about it, like generally, he's like, oh, I was looking for SM info. And I'm like, I said SM info. I didn't say that to him, but I thought in my head, I'm like, did this motherfucker not hear me say SM info? Like, that's the first thing I do. But at the end of like all my like explanation about it, he's like, oh yeah, SM info is what I wanted. And I'm like, oh, well, okay. I guess he didn't hear me. But anyways, I don't care. Like they can go look for somebody else, and who cares? High performance compute is, I got a whole is it a use? I have a whole like talk on HPC and how it differs from normal PC. It's high performance clustering of large systems and submitting jobs and then having things talk over job managers and large networks and secondary networks and tertiary networks and then all kinds of things. Yeah, totally different software. Yeah, totally different, all kinds of stuff. I have a whole talk on it, but we're not going to do it right now. And by the way, as I was talking about the other day, there is a Ubuntu HPC thing that they just started as an initiative last year, and then also the Linux Foundation. They just announced their own high-performance compute stuff. So, like, other people are seeing the value in these things. The Ubuntu Canonical, and then also this as well. So, yeah, they've got talks and what are they trying to do and what are they trying to figure out and make better and all of those things. Yeah, my talk is on YouTube, yeah. Also, not only is my talk on YouTube, the presentation is here. So if you're like, oh, there's some good links in there. The presentation is high performance compute right there. So it's in there, right, if you need that. All right, so let's talk about Ansible automation with Tower. And this was a talk, again, that I gave to Redline a few years back and was trying to get more people to use Ansible. And then I just got the question, like, what is Ansible? How does Ansible work? Why do we want to use it? And that kind of stuff. Well, here's kind of my agenda. What's the central problem of systems engineering on the ops side? Like, what are they? How are they? How do we try to fix them? What is Ansible? And then how can Ansible fix those problems in systems engineering? So, is it a use? That's fine. Yeah, I like questions. They keep me going. In fact, I only went over to this because you asked about Ansible. So, then what does Ansible do? How does it work? All that kind of stuff. And then I've got a little Tower AWX demo where I'll show you guys how this works. Now, again, in the industry, in the enterprise, Red Hat, Tower is now called AAP, Ansible Automation Platform. But when I wrote this originally, it was Tower. So we're going to go with that. So what are the central problems of systems engineering, right? Like, you want to run a high-performance compute cluster. You want to run, like, all of platform engineering for, like, AAA, like I used to do. And you've got thousands of computers, and you've got the ability for somebody to push a button somewhere and just pop a server out, and it should be a working server when they get it. What are the problems? So here's two major problems in systems engineering in those two things I just described. One is consistency. One is, Steve sets up a server build-out procedure, hands it over to Dave. Dave builds the new servers, but they haven't got updated file locations. So now you got a bunch of different versions and conflicts of server software. Steve has an updated procedure, but he hasn't sent the new one to Dave. So now you got people building stuff in your environments that are just, they're just a mess, right? It's everywhere. And then there's another side of this. There's timeliness. Steve can kick off his local scripts and build servers in an hour. The rest of the team takes 3 days, mostly because they're asking Steve for help. Well, that's cool, I guess. That's the way we used to do it. But why don't we turn these things into an automated process? And this is what a lot of engineering teams have spent the last 10 years, especially in the systems engineering space, is how do we consistently deploy the same type of node? And then how do we get timeliness around that deploy? And both of those things deal with having an automated tool that works in some way. Different people try to solve this different ways. There's Chef, there's Puppet, there's SaltStack, but there's also a tool called Ansible. Ansible, though, by itself doesn't do all the things. So anyways, how do we attempt to solve these problems, right? We've got these two central problems, consistency and repeatability and timeliness. So how do we try to solve them? Well, there's an ITIL methodology, and we're up to ITIL 4. I did the ITIL version 3 back in like 2016. But it makes us kind of take everything that we do as engineers and turn it into a service. It's like when you come to me with an engineering problem, I stand there like a waiter, and I put the little menu out, and you can pick the things that you want from the services that I have. Like, I can build you a server in 5 minutes, and it can be Linux, or it can be Windows Server 2019, or it could be Data Center Edition, or it can be just a dev environment, whatever. It's like we're a restaurant and we define the menu, but it doesn't actually help us in the back preparing those dishes any, right? Oh, we can have a nice menu, but you're still going to have people in the back building out the servers, and you're still going to have these two problems, right? So again, we want to figure out how to do this. So then we've got these DevOps methodologies that exist. And the DevOps methodologies try to pull the hardware provisioning into the software lifecycle methodology. Everything produces artifacts, acceptance testings, becomes automated, peer review before going into production. There's all these good practices, but even that doesn't quite build our servers for us. We still got to figure out how we're going to build these servers. So there's a kind of idea to DevOps, this DevOps methodology, which is that dev is always spinning. Anytime I commit code up or do anything, we're just spinning through iterations of deployments and testing to make sure that things can come out the way that they need to. But it says this image below tends to be running in dev test prod environments, which further complicates things. The goal is to keep these iterations tight and always working. Continuous automation, automated building tests, and continuous deployment testing. So this is kind of like a CI/CD pipeline right here, where things are always spinning, and then when we're ready, we cut these over into prod after we've done an acceptable amount of we do regression testing and unit acceptance testings and smoke testing, and we do all the types of testing. And then when we're ready, sometimes we even do load testing, and then we move it down and we get ready to deploy in prod. Yeah, Curso. Yeah, so the point of this spinning is to get to a deployable working thing and then be able to go to the next one and the next one rapidly. Yes. The goal is to receive feedback about broken stuff as soon as possible, not to keep it spinning. Sure. Yeah. Dev is always spinning, though. As you deploy some bit of code or you update whatever's happening, we go through all our tests automatically and we prove that it'll work. Okay? So those are things that we kind of do. This is kind of a DevOps thing, right? Things are always spinning, tests are always happening, and things can fail. But that's just a piece of feedback that can then be used for whatever thing. Okay. So then we get down here and I say, so what about Ansible? If I'm talking about all these things, what does Ansible do? How does it help us? And this is what Ansible does. Somebody asked earlier, what is Ansible? So we jumped over and started talking about Ansible. Ansible is just a configuration tool, and it runs agentless in an environment. So one head node can control as many nodes as you can point at, which is very valuable. By default, it uses SSH protocol port 22 for all your Linux boxes. Windows, you can use WinRM on port 5985, or if you want to use secure WinRM, it's 5986. But those are the defaults. You can also change those. What it does, though, is it connects over there. It checks for the existence of Python. Python must be there. Then it uses individual modules that can be individually added or removed from execution based on calls and different stuff. And a module is well-defined and easily referenced online or within an Ansible doc tool. They're all written in Python, so they use Python-esque conventions for filters and all those types of things. Variable usage follows Python conventions, very easy to use. And then modules exist to make use of Jinja 2 templating, and you can easily send things to email or Slack or Discord or Teams or whatever, but it's very easy to send things out and be able to track what's happening in your environment. It's very kind of useful as far as just maintaining and building systems and those kind of things. So that's what Ansible does. If I sit down at a box like this and I say, okay, what does Ansible do? Exit out of here. If I Ansible all -m shell -a uptime, I can hit all of the environmental configured nodes that I have and see what their uptime is right here. Right? So assuming Ansible's there and assuming there's a well-structured config file that exists, and there is in my home lab. And I can see how long my nodes have been up. I can see a bunch of information about them and all that kind of stuff. Easy, but not very scalable. Ansible is more scalable when it runs locally in parallel on hundreds of machines instead of SSHing into each one. KSOR, yeah. So you're probably a little newer around here, but for me, I actually have a model where I've done that on like NOAA, when I built out all the NOAA high performance compute, and that's NOAA. When I built out all their nodes, yeah, I can get all of their nodes up and running in under 5 minutes because Ansible configures itself on each machine. So yeah, there's actually a a model for that. You can scale up for searches like this, and if you're doing, like I do some reporting on systems, you can scale to hitting about 300 or 400 nodes if you have a box that has, like in my case, I have a server that's got 128 cores and 512 gigs of RAM, so that one can hit about 300 or 400 nodes without really going too hard against it. But for the most part, it does start to get very arduous to the system because of the memory requirements of holding all the variables. But yeah, you don't scale well hitting SSH to a bunch of machines for configuration reasons, that's for sure. Although Ansible can be distributed and it can be done like that. But in this case, I'm just saying Ansible from like a tool that goes and SSHs to a bunch of boxes. I use this all the time to configure smaller subsets of my environments and those kind of things. But I also use Ansible in an inverted fashion where it pulls configurations down to nodes, and that's super valuable as well. But even in that case, the node is still configuring itself. You can also use chroot. I've been using chroot in some of my environments to harden to the STIG standards. Pulling out of a Git repo and running Ansible locally is my favorite model. Yeah, Q. I actually have a lab for that, and it's funny. I don't think I've ever actually done this lab with you guys, but I have a lab in Killer Coda. You guys have the link to all my labs and stuff, but down in the Ansible labs, there's one right at the very end, very last one. I don't think I've ever actually done it on stream here because I never finished it to make it really go live. But all this lab does is this right here. It's what you just described. Is you just set up, you git clone down the Ansible HPC deploy Git repository that I have. Once it comes up, scenario is still coming up because it's installing some stuff in the background. Yeah, KSOR. There's some good uses for Ansible for sure. All right, so I got that CD in there, and then I can just go look, and like in this case, I can just run NFS everywhere. This is going to break though, and then I ask why it breaks the first time but works the second. But then I have a little question there, like, why did it break? And then people can go and look and say, well, why did that break? Why did the NFS server come up, and then the client came up, but then when I went to run the handlers, it broke the first time. But then I rerun it the second time, and it works. You're like, what the heck? Why is this breaking down here? You're going to see it's going to break when it tries to connect right here. But it's like, well, why? And there's maybe a reason for it. If you go look at the execution and how these things happened. So then you got to go dig in a little, right? This is going to break right here. But if you rerun it, there's a reason this broke. There's a reason that probably should have happened earlier. Now when you rerun it, it'll work. The things that already happened don't have to happen again, though. But that's a description of what was just mentioned there, guys, over on the Twitch side. Is it a use? What we tend to use... so there's two things that happen. Let's go back here. There's two things that happen in a systems engineering sense when we bring servers up. So you asked, do I think it's Ansible useful on a cloud where we specify startup scripts and then bring up the machine? There's two ways to start a machine. There's pre-baking things, and then there's what is commonly called like a startup script or user execution space later, right? Or what I like to call personalization. So pre-baking is I build everything into an image, and then I use that image to deploy servers, right? And then personalization is things that come on after, where maybe in the environment as it comes up, I need to go pull a secret or something and get like a connection to a database or something like that. Yeah, so, or is it mostly for bare metal data? Is it a use? I use Ansible for all kinds of things, and it really depends. I use Ansible even to stand up resources out in AWS. It works just fine for that. You can also use Terraform or some other tool for that. Or you can use Ansible to kick off CloudFormation templates. There's a tremendous amount of power, and I tell people all the time, like, don't get locked into any one tool. Because there's reasons to use different tools for different things, and some excel at it. But I love using Ansible for configuring. Like, if an environment's already stood up, and often I get called as a employee of Redline. I get put into environments where like they need me to fix or build things that are already there and make them better. And I use Ansible almost exclusively for stuff like that. Like if I got dropped in an environment with like 15,000 nodes and I needed to solve some problem, I would probably be using Ansible to deploy my solution almost universally. So this is what Ansible does. And then this is one of my favorite little presentation. This is one of my favorite things I've ever made. But what does Ansible do by itself? Ansible is inert. It just sits there. It lays there on the floor doing nothing. You have to kick it off just like a shell script. In that respect, the tool itself is, I mean, yeah, you can have a service call it as a box comes up, and there's a bunch of other things. But my point is, Ansible all by itself is simply a command line tool, right? So we need to use something like AWX Tower, AWX or Tower, which is the Ansible automation platform now. But how does it fit in to make like your DevOps idea of systems engineering better? So we hope the team writes some good Ansible code and they commit it up to Git. And then systems are constantly running builds against the code or the commit or whatever. And they're constantly doing that spinning thing that we talked about earlier. So we can automatically build to verify things are working. That fixes our timeliness problem. And then we can provide other engineers access to work and they can see the job over and over again with no mistakes. So there's consistency. Like as people are adding pieces in over here, they can see things happen quickly. So this is kind of that spinning in the background model, right? And then every time the builds are successful or they fail or whatever, we can write them to certain Slack, email, Discord, Teams, whatever you want, right? So let's go look at, where's Tower? So here's my Tower in my home lab. My Tower does things every day in my home lab environment. It looks like something failed. I've got schedules and I've got templates and I've got things that are running over here. And if I was writing stuff and actually causing things to happen in here, there would be things that could, there would be things that would happen. Like I used to have patching daily running, those kind of things in my environment. Yeah, so we've got a bunch of stuff here, and then like in this case, my Bastion deploy, every time I run that, tells me if my job was successful or not. Last time I ran that was February. Man, that seems like that was a long time ago. Okay, we ran it at the end of April, it looks like. That's the last time I've deployed or tore down my Bastion. I can go click on this and look at how that run actually happened. If I want to go see what that run looked like. It was successful, and it did write out to our sandbox. So this Bastion deploy actually writes out into our Discord every time in our sandbox. I've got other stuff that writes out there too, but in our sandbox, here's my lab environment stuff, right? This writes out every morning, lets us know how much the lab's been used. That's the home lab. But then we go up a little bit and we find, I don't know how long back this would be. This should be only to April. Excuse me. Go back a little bit. So here, back in April, we see that the chroot jail has been deployed to allow systems to pass through with Streamer. And here's some password that I made for it. And then the dungeon system password jumps over to the last set of servers or whatever. So this is actually a way to hop into the system when I have the Bastion host set up. And some of you guys have been around where we walk through the Bastion host and all that kind of stuff. So there's that. Okay. Let's get through this. Oh, what happened? I went to the end? Oh no. Let's get to where we were. Okay, so we were here. So Tower capabilities. What does Tower do? It's got role-based access control. It can tie in with Azure, GitHub, Google OAuth, LDAP, Radius, SAML, TACACS. I'm sure there's even more nowadays, but my version can do that. Organizations and teams. Organizations, users, teams, you can define them for granular control. And what I can do is I can take that permission set that I have, which is like the for deploying the Bastion, and I could give that to like Robodom or something. And even though he doesn't have root in my environment, he can kick that off inside a Tower and use the root user that I have defined in there, and he would be able to use that to deploy that system, right? There's also inventory management. Not all of us like to do static defined inventories. I generate statically defined inventories every day in my environment, but they are still dynamically generated. But you can define inventories if you want. You can get them out of Git. So you could put your inventories up in Git if you wanted to, or GitLab or whatever you're using for your organization. We can write inventory scripts that go and they pull them from cloud providers. You can pull it out of Satellite and other tools. I use Satellite mostly for that because it's an excellent way to see all the systems that are registered and what you're actually paying for, then compare that to whatever other sources of truth you have in your environment. And Ansible does the Python compares, so it's super easy to tell, hey, things are over here in this pool or this bucket, and they're not over in that bucket. Then execution, it pulls out of GitHub repositories. Credentials can be stored and then given via RBAC. Templates can run. You can set up surveys. Surveys will allow you to fill out information. So like if I come back over here and look at this, if I go to run this job right now, I'll just go to the template, and I'll say I want to run this Bastion deploy. There's information that I still need to give this. Do I want to make it present as I'm installing it, or do I want to not have it in absent? So I have it present. Then it's streamer 1, and then I can say like this is the password, right? And then that gets too long, so maybe I do something like that. This is a pass 1, something like that. And then do I want to report out to Sandbox, yes or no? And then I hit next here, and this will go and it'll build. It'll build this out, and then it'll report it out to my Sandbox inside of Discord, right? And that makes it a lot easier for me to deploy things and see how they work and all that kind of stuff. Even though that's not like being run on an iterative process, that's just me spinning and kind of building those things or whatever. So those are Tower capabilities. Then we come down here. Here's like a dashboard view, an old dashboard inside a Tower. Well, this is AWX, the free version. There's still a free version out there, even though Ansible is owned. Ansible is owned by Red Hat, and then Red Hat's owned by IBM. So, through all that, you can think about, I'm surprised it's still as free as it is, but there still is an AWX tool that's out there that you can deploy. Although nowadays you do have to deploy it completely through their method. So if you look up AWX, I haven't been in here in a long time, but after like version 19, you have to build it through their whatever it's called. Here's their install guide. Yeah, you got to use the AWX operator after 18. And I'll be honest, I've never gotten the AWX operator to work right. I don't know. I've talked to a few people, and they all have a problem with it as well. It's supposed to be the easiest way to do it, but yeah, I'll let you guys go play with that if you wanna see if it's as easy as they make it sound, because I don't think this is easy at all. I think that this looks like it's the most convoluted, messed up thing that I've ever seen. So, yeah, I don't think it's great at all. Here's their documentation on it. It's just a mess. Not worth my time to mess with. So here's my little dashboard view. I use it. It works fine for me. Pipeline demo. So we'll set up AWX, pull from Git repositories, pull a project, pull an inventory, run the Ansible job automatically, or set up a schedule, build Jinja 2 reporting templates, and then report the play out to the team. So in my home lab, I'm not going to do all that for you guys, but when I did this originally, this Bastion deploy test, if we go click on it and look at it, it is part of this project called Bastion Deploy or Bastion Project Test. So if I go to project here and go look at Bastion Project Test, this goes and it pulls from a GitHub somewhere. That GitHub is my GitHub here, right? And that code is called Stream Setup. And if we go into Stream Setup here, here's my Bastion deploy. It's this whole big setup. And if we go in and we actually look at the tasks around this main.yaml, here is my Ansible. Here's my Ansible that does all of this deployment. It's a chroot jail. It passes through just what people need to be able to connect to my external system and do all the things that it needs. That's true. Ansible is only idempotent if you write it that way. True. This playbook is idempotent. We can run it over and over again. But It does all the things that it needs to, adds all the pieces, and then allows for that pass-through. And if I give the proper variables, if report is set to yes, it'll report out to Discord if the Discord webhook exists. When Discord webhook URL is defined, it can do this. Otherwise, this whole block right here, this block right here does not happen unless report is yes. If report is not yes and action is not absent, then it won't do this block. That's a block for user being absent. And then there's a block for user being present up here. And we also can report or not report. Yeah, so there we go. Boom. These are the pieces that we have. You guys can go pull that. That's a open and public repository. But the master branch is deprecated nowadays, so most people do things as main instead. But then here, if I were to run this and I were to have made a change there, I can have these different options for when we run this. It's not in there. It's back in here. We have options for when we run this. Does it go and does it pull that every single time? So here is it's going to do clean. How's it going, Harold? We are just working through some Ansible talk. And clean is going to be remove any local modifications prior to performing an update. So if I changed anything locally, it would pull it. And then update revisions on launch. Each time a job runs against this project, update the revision of the project prior to starting the job. So this means it's going to go and it's going to re-pull that master branch. Again, most of these modern ones aren't going to be master. They're going to be main, but they're going to be there. Also, Harold, what were you guys working on over there? I imagine you were working on the bot in some capacity. And I'm surprised that I was on later than you. Normally I raid over to you or some of the other guys, but tonight I was working through. So what was I doing tonight? I started out through this talk here, which was the Prometheus Certified Associate, right? And we were talking through all of these things that I've been putting together. And these are the study things that I'm using because I'm getting ready for that cert, right? And then I had a question about Ansible and what is Ansible, and everybody always hears about it. And I was giving a little talk that I put together for my company Redline a few years back around how Tower and Ansible work. So Ansible in and of itself is just some configuration tool that goes and runs agentless in an environment, right? And then we were down, looking at how these different things work. And we were talking about doing a little demo. And then, I was saying there's all these different tools that are out there, but Ansible can do a lot of this. Ansible can do the deploy, and it can do the operation, and it can even do some of the monitoring. I use Ansible in a surprisingly simple way to see the monitoring of systems. And in my sandbox here, in my home lab sandbox, right? Let's go jump to the most recent one. Every morning, I do this same thing professionally at work. The only difference is instead of saying 10 total systems, it says 1,211. And what it does is it says that it checked all my servers. It tells me if any are unreachable. And you say, well, doesn't that get really big? Well, yeah. I mean, if you've got a node system of 1,211 and you've got like 400 nodes down, well, you probably got some other crap broken. But if you have like 10 nodes down, that's fine. They'll be on a line right here. And then I want to know if any of my systems rebooted in the last 24 hours. Reboots are where a lot of problems happen. So I want to know when reboots happen. And then I want to know, did any users log in the last 24 hours? And nobody's been using our home lab system. Nobody's been using it. But somebody used it a few days ago because I got, it's been a few days now, it looks like. Somebody used it. People logged into Red Node 03 and Blue Node 01. So there's that. And people that want to get access to the home lab, all you got to do is ask and in the Discord and let me know. And I've got the method for you guys to go here. If you guys have never seen Guacamole, Guacamole is a simple little tool like this. I got to get the certificate set up, but Guacamole is a little tool like this. And you drop in here, and then you can go connect to any of my lab nodes. And this would be right in your browser, just like this. Right? And then I could bounce out, and it would jump me out to the home again. And I could drop out of that, so I don't need like any special tools to connect or anything. And then over back in my lab environment, if I change this to Dungeons, I should be able to see... Oh, well, something else is going on in Dungeons. Let me switch this to our Dungeons environment. Where's our Dungeons environment? I haven't looked at this in a while. Somebody help me. Dungeon status. Here. We should see, right here, if we go switch to... If I switch this to dungeon, there's my connection when I was just in there, and there's my who am I and my hello stream coming out there, so I can see all the commands that people did when they connect in there. By the way, this app, it's messed up. I need to fix my environment, so hold on. My variables here need to be app needs to have a default value. Where the heck's my default value? Somebody help me out here. Label, query, app, hide, sort, disable, regex, query type, data source. I need the... I don't see it here. Include all options, sort, disabled. I don't see where my default is. Hold on. Name is app, type is query. You guys see it? I don't see it. I'm lost, guys. I don't see it. I should have... I don't want to change any of that. Alright. I don't know why that variable... Don't want to do none of this crap. Alright, hold on. I need to see if there's a way to set the default app variable, even if it's just in the dashboard. I can set the time zone to default. I don't see it anywhere in here, but I should be able to set that as a default so that I can always see this when I come in. See how it looks busted? But then when I do dungeon, then it gives me that somebody was in the dungeon. I can see all this stuff that was going on there. Oh, I also see when I hopped in there earlier and I was looking at all the that's all the Prometheus data from that node that I was in. So, all right. Anyways, guys, we're just messing around here, but we're looking at systems, figuring out how they work. And we were doing Prometheus earlier, so there's some good stuff in there. Then we were in our Ansible talk, and we were talking about DevOps. There's a lot of pieces and a lot of tools. You're not going to know all of them, but you got to get to the ones that you're good with. And Ansible tends to be one that I can do a lot of these different pieces for. All right. And then what's my last piece? So, the summary, it's not a start, but it's not everything, but it's a start. And this is kind of the idea that dev teams and ops teams have always kind of had this wall between them. I used to support about 200 dev teams. 200 dev teams in one company, yes. And they would be coming to me with all kinds of out of the pocket, insane requests for what servers could and couldn't do. And with this idea of DevOps, it's that we're kind of working together more. And as a systems engineer and as like a platform guy, I say probably now about the last 10 years almost, there's been a tremendous amount of me having to go across to their side and learn about the CI/CD, and I had to learn Git, right? I'm a Linux engineer, guys. When the F was I ever supposed to use Git? Nowadays, I use it all the damn time. All the time. I'm always pushing stuff up to Git and pulling things down and doing code reviews and stuff, because that's kind of where this goes. Like, the years of me just being left alone in a data center and back in a server closet and nobody bugging me are gone. And maybe that's because I've moved up over the years and that kind of stuff. But also, junior engineers have to sit in meetings and talk through with our dev guys, and they have to understand. So I would tell you, like, learn these tools and learn how these different things work, because they're important. Even if you think like, oh, shoot, I just want to be that guy down on the, on the systems engineering side of things, and I don't want to be dealing with all that other stuff. People run apps on top of servers. That's what they do. Servers touch networks. Like I tell people all the time, you're never going to get away with being a network engineer. You might say, I don't want to do it that much. Yeah, but you got to make your servers work. Yeah, you can't. The guy down in the basement doesn't really exist anymore. And I can promise you, I wanted to be in the basement more than any of the rest of you. They've been trying. I tell you guys all the time, and you guys think I'm joking. They've been trying to make me a manager for 20 years. And I just stay away from it. I'm like, I'm not doing it. I already wipe enough noses and dry enough eyes and do all the tears and stuff from the little babies, where I teach, right? So, like, I don't want to do that professionally. So, I already get that from the college side of things. Yeah, and full stack has to come towards us, and we've had to go towards them. And being able to quickly iterate through, like standing up your own little Docker instances. That's probably something most of you software guys didn't think you were ever going to have to do. But now you got to do it. All right. Oh, Veer asked if I'm ever thinking of any plans to do a video on setting up a home lab from scratch. Yeah, I mean, I have a lot of stuff where we do the home lab and we mess around in my home lab, but doing it from scratch, man, anymore nowadays, I would tell you guys to just go use the free stuff out in the cloud. But I would gladly do that for you guys if you want to do AWS stuff for sure. And how to even stand them up automated and then tear them down automated. I think that would probably have some value for some of you, and we could do that if you guys wanted. Some of that stuff might be, instead of doing that online, some of that stuff I might just want to do down in the Discord with everybody, because I would gladly do that for everybody. Yeah. Absolutely. So then I have questions, and feel free, if you guys have questions, send them over to me in the Discord. We've got a section actually in the Discord. If you're ever on stream here, and look, guys, you can hang out in the Discord or not. Like nobody's going to make you guys do it, right? Like I'm not holding anything to anybody's head and telling you to do it. But we do have a little place here where you can, if you have a question from stream and you're like, hey man, like at this minute, or I clipped this thing, can you go show me? Like, feel free to ask it in there and I'll try to answer it. And so will some of the other more senior people that we have around. But you guys are welcome to ask. And by the way, if you have topics, if you're like, hey, I'd really like you to go over this topic, like what Veer just mentioned, like just a lab from scratch. I think that would be kind of valuable. So maybe I'll put something like that together. But let me look into that, because I'll have to figure out how I would want to do that. But I also have the lab environment for you guys to jump into, in case you don't have the capability of doing your own home environment. We always have the Prolog labs up on Killer Coda. Those are completely free. Like, the idea that there's somebody out there that gives you free infrastructure through a browser to do like almost anything you need to do and set up is just, it's wild to me. Is it a use? I don't have a talk on storage just yet. I do have some drawings that I put together for storage. Storage on the cloud, I do have some talks on that stuff. Yeah, if people are looking at. Yeah, they did close out Catacoda. Yep, and then Killer Coda is very similar. In fact, there's actually parts of Killer Coda that show people how to convert over their Catacoda environments. And I didn't ever do anything with Catacoda, but it's pretty similar to that. Yeah, you just drop into a browser like this. You say, hey, drop me in Killer Coda, and give me a server. They will give you immediately a single node Ubuntu server just like this. And they've never charged me anything. I've been using this for like 2.5 years. They've never charged me anything. So they give you an option to pay them. Look, and like, if you guys like it, feel free to pay them. I have no affiliation to them, like to say one way or the other. But I really do believe in this product. So if somebody does want to pay them, please feel free to. They've also got a Slack you can go join, and you can get in here and you can say, okay, I'm on an Ubuntu box. Who am I? I'm root, but I don't feel like I'm root. Why don't I feel like I'm root? Well, it's because my PS1 variable is set to a $, and that's not what I'm used to. So maybe I set my PS1 equal to, something like this. Oops. That feels more right? That kind of stuff. You can play with Docker in there. You can go do, I have a full thing out there where you can do like, I got all kinds of crap out there for you guys to play with. But they're free environments, man. It doesn't get any better than free. Like it costs as much to do that as it did to sit here, and you could really just go in there and play with stuff all day. Like, you're like, oh, I kind of want to play with this Istio. I've heard a lot about Istio, but I don't know, is Istio any good? Now here's how to set up Istio environment right here. Look at this. This guy's got what is that? That's 16. That's 18 environments of Istio that I can stand up. I don't really know what Istio is. I've turned it on before in a lab, but I've never played with it. But I know that I can get 18 hands-on labs right here. It says Istio's already installed. It's been downloaded. Boom. Guys, I'm not an Istio advocate. I don't even think I've ever used it. Again, except for maybe some lab stuff. Download istio.shell and it'll install. It's going to install Istio for me. Boom. Now I got hands-on experience, and I've never even. I mean, I'm not telling you to go put it on your resume right away, but you have more experience doing this lab than I do. If you do all 18 of these labs, you could probably put Istio on your thing. Yeah. So what's keeping you from being? Oh, look at this Istio stuff. Look, it all got stood up. Here's some. Now I got to go start using some of the stuff that I know about services, and then I go, okay, service. There's an Istio egress gateway, which is cluster IP load balancer. I know what those things all are. Okay, this one's pending because it's not going to actually get an external IP. Here's the cluster IP, so I should be able to hit any one of these. So I should be able to do something like this, like kget service, and you can use K or Kubernetes, right? Kget service Istio gateway. That's service. Is that in a specific namespace? Yeah. All right, so it's in a specific namespace, and I see it, and I go, can I describe it? Because mainly for me, when I describe services, I want to see that the endpoints are going somewhere. In this case, 192.168.1.6 on port 8080. And then I come up here and I go, let's see if I can get the pods for that. So k get pods in that system, right, in that namespace. And I'll say dash show dash labels, right? So now I'll get the labels. And one of the selectors here is Istio egress gateway and Istio egress gateway. So when I look at all these pods, the Istio egress gateway has the app Istio egress gateway. So that's going to match there. And then it's going to have down here Istio egress gateway. So here's the two selectors. So this Istio egress gateway, when I do show labels and then -o wide, should have the 192.168.1.6 IP address. And that makes sense because this service was going to use its selectors to select its pod as its endpoint. And that's how we do that. That's how we know how these pieces work. Thanks for coming by, SK. Hopefully this stuff's useful to you. Veer, you said in your own circle you have a few friends that always love to build a home lab, mess around, but not much information for beginners to start with. Having that will be awesome. Thanks. Yeah, Veer, I will look into it. And I mean, a lot of we do have some lab stuff in the Discord as well. But like one of the hardest things is getting everyone the same hardware and the same equipment. That's one of the reasons I like stuff like this is I can get you guys all in the same environment as me. By the way, that environment's gone forever now, so that's awesome, you know. And then I can come here and like you can build a lot of stuff, but without having to have that overhead in somebody's home or in somebody's system, you know. All right. So anyways, there's that. There's that. There's Ranger. Look at Ranger dog. He looks so sad, but I assure you guys, Ranger is quite pampered. So don't let him look sad to you. He's pretty all right. There's my home lab of Prometheus. I need to leave that up because I got to keep practicing as I'm getting ready for the test. So that's there. I need to finish up the cleaning up of this to put this up in the Discord as well. But that's probably where we'll end it for the night. We're at about 2.5 hours. For people that haven't been here before, again, you guys are welcome to hang out down the Discord. We'll go to our little end of stream. We'll go find somebody to raid. Hopefully this stuff's useful to you guys. And yeah, let's see if there's anybody to raid tonight. We'll go hit up Blaze Bits. If you guys haven't been over there, wait, there's Try Hack Me Live. I don't know him. I don't know any of those guys. We'll just go hit Blaze Bits because he normally raids me, so we'll raid over there. So, all right, thanks guys, and I will talk to most of you tomorrow night. Take care.